Okay, we're going to take a quick look at some transformations. So question 1 is looking to reflect the shape in the line with equation x is equal to 1. The first thing we need to do is identify where x is equal to 1. And just remember, don't get yourselves confused. The tendency is to look at where 1 is and then potentially get this the wrong way round. So in this example, x is equal to 1 at the point on this line where x is equal to 1. Quite often, because this is the horizontal line and that kind of runs parallel with the x-axis, people think it's this line here, but actually in fact the horizontal line is where y is equal to 1. So when we've got x is equal to something, we must make sure we draw in a vertical line. So I'm going to draw that vertical line in. So at all of these points on this line, x is equal to 1. Y is changing, but x is equal to 1. So you'll get the opportunity to use tracing paper, so I suggest that you take it. The first thing we're going to do is I'm going to place my tracing paper over my shape, and I'm going to put a little mark on each of the top and the bottom corners of where I've just drawn my line in of where x is equal to 1. I'm going to trace my shape on my tracing paper, and then I'm going to just gently shade in over the top like so. Once I've done that, I'll turn my tracing paper over, line up my little points that I've marked on my sheet, my corners, and then I can see through my tracing paper my shape, so I'm going to draw my shape in like so, just over the top, and then you can see underneath there's that shape that's faintly drawn in, and then I'm just going to go over the top. So this is my reflection of my shape in the line with the equation x is equal to 1. Okay, now I want to have a look at translating shapes by vectors. So I've got my shape on my question, and it wants me to translate by the vector 5 minus 4. So it's worth noting a couple of things here. This is the x value on the top, so remember x comes before y, so x is on the top, y is on the bottom. If x is positive, then we are going to the right, we're moving to the right. If x is negative, we're moving to the left. If y is positive, we are moving up. And if y is negative, then we're moving down. So in this case, we're going 5 to the right, and we are going 4 down. So that's the first thing to note. How we do this is we identify a corner, so I'm just going to pick this top corner here, it could be any corner that we choose, and I'm going to move that 5 to the right, 1, 2, 3, 4, 5, put myself a little faint dot, and I'm going to move that 4 down, 1, 2, 3, 4 to here. And effectively then I've translated this corner here by 5 and negative 4 to this corner here. I can now just copy this shape, so I'm going to draw a line 2 down, 1, 2, 3 squares across, and then I need to just draw that corner in like so. So I've translated that vector by 5 minus 4. Okay, so we're now going to have a look at enlarging shapes, and this shape we're going to enlarge by a scale factor of 2. This means it's going to get 2 times as big, twice as big, and we've got a centre of enlargement at the coordinate 2, 3. Remember, x comes before y, so we're going 2 across and 3 up, and I'm just going to put a tiny little dot with a very sharp pencil just where my centre of enlargement is. The next thing I'm going to do is from my centre of enlargement, I'm going to draw lines that go through each of the vertex, so each of the corners on my shape. And I'm going to get that really accurate because I'm going to use that to check that when I've got my final answer that this kind of works. So you can see there I've tried to cut through that corner there. On this ray line I'm cutting through that bottom corner. This one is the top right corner, like so. And this one is the bottom left, sorry, bottom right. So we're going to go through like this. Now, Okay, so now what I need to do is I need to find how I kind of get from my centre of enlargements to each of my 4 corners on my shape that they've given me to start with. So I'm going to count 1, 2 across, so 1, 2, and then go up 1, 2, 3. Because I've got a scale factor of 2, I need to do that again. So I'm going to go 1, 2 across, and 1, 2, 3 up. And I'm going to draw a little dot there. So this dot here is the same as this little corner here. Now I'm going to work out how to get this corner enlarged. So I'm going to go across 1, 2, 3, 4, 5, and up 1, 2, 3. I need to do that again because I've got a scale factor of 2. So I go across 1, 2, 3, 4, 5, and I'm going to go up 1, 2, 3. So I'm going to put my little dot there. Now, I know that I've now got these 2 corners plotted, so I can just complete my shape. I don't need to do my counting. So I'm going to join those 2 dots up with my ruler. So just join those up. And instead of going 1 up, remember I've got a scale factor of 2. So I'm going to go 2 squares up because I'm going to double it. 2 squares up on this side. And then I'm going to come across and just join those corners up. And if you can see from the ray lines that pretty much our ray lines are crossing those 4 corners that we've drawn. So we know that we've got our scale factor of 2 enlarged by the centre rotation 2, 3 correct. So that's how you enlarge by a scale factor of 2 around a given centre of enlargement. Okay, the next question they want us to have a look at is actually describing the transformation. So I can see that this is an enlargement because it just looks like it's an enlargement. It's obviously got bigger, so it must be an enlargement. And the thing we're going to do here is just draw up in the same way that we kind of did the opposite of before. We're going to link up and draw a line between each of the corners. So this corner matches with this corner, so I've got a nice straight line. I'm matching those 2 corners on the top right, and I'm going to match these 2 corners on the top left. And where these meet, so they're all meeting at this point here, this where they meet is my centre of enlargement, so I'm just going to put COE. So my centre of enlargement is 12 on the X and 6 on the Y. So that's my position of my centre of enlargement. And I can see this A shape, and it's important to note from shape A to B. So it's from shape A, which was 2 across here, and here it's 4 across. So the scale factor from 2 to 4, well, I've multiplied it by 2. So I've got an enlargement from the centre of enlargement, and write this out in full in an exam. Enlargement from centre of enlargement at 12,6 by a scale factor of 2, and that's how I would describe that particular transformation. Okay, we'll have a quick look at some rotation now. So this time we need to rotate the shape 270 degrees anti-clockwise about the origin. So the first things we need to make sure we're happy with is the origin, which is where we cross in the middle. Remember, they might give you a coordinate, so you just need to be mindful of where they're asking you to rotate from, and just make sure you get the direction right. So anti-clockwise is that way, so we're going to go anti-clockwise and rotate the shape that way. So I'm going to get my tracing paper. The first thing I'm going to do is put a cross in where my origin is, and I do that for wherever they were asking me to translate, because that just helps me determine how far I've rotated. So I'm going to draw very carefully the shape, turn my paper over and just shade over the back, like so. And then I'm going to place this back on, and I'm remembering that I'm doing 270 degrees. So remember, for this bit here, we're doing 90. So I'm going to turn my paper, put my pencil there to help me keep it in the right place. 1 turn is 90 degrees, 2 turns is 180 degrees, and then that 3rd turn is going to give me 270 degrees. And then I'm going to go over the top of my shape that I've drawn, like so, and that will leave me an imprint on the other side, and then I can just fill that in. So I'm going to use my ruler. I'm going to go 2 across, up to the top, down to the side, and then join those ones up. So then we can see that we've rotated that shape 270 degrees anti-clockwise about the origin. If we now look at question 6, it's asking us to describe the single transformation again, so from shape A to shape B. So I'm just going to look, I can see the shape hasn't moved or changed, it's just, well, it has moved, sorry, but it hasn't changed, it's not bigger or smaller, it hasn't kind of changed its anything aside from its position. So I'm going to pick a corner, this corner here, and I'm going to see how many squares I've moved to get from this corner to this corner, because it's from shape A to shape B. So I've gone 1, 2, 3, 4, 5 up. So I'm just going to write that down, 5 up, and I've gone 1 left. If we look at back up here, we know that if we're going up, we've got a positive, and if we're going left, we've got a negative. So our x value, so this is our y value, this is x, so our x value we've got -1, and our y value we have got 5, so our vector is -1 over 5, so we have got a translation by the vector -1, 5. So to summarise transformations, obviously we haven't done negative scale factors, we haven't done fractional scale factors. You need to have a look through your books to make sure you're happy with those things, or find another video online, but this is just a nice quick reminder of the very basics of transformations.